Well, thanks, Ronnie, for the introduction, and I'm happy to be here today with this panel with Laura and Tim. I think we've got some good presentations to talk about feed mill biosecurity and talk about some different strategies to help minimize risk in the feed mills. And again, want to echo what Ronnie said as well, too. Really appreciate all the diehards that are still here this morning as opposed to trying to catch that early flight home. And so thanks for the attendance. And what I want to do is start off a little bit by saying that probably when this session was drafted and written up and organized, the thought process was based off of the connection between PED and feed, and the reason why we're going to focus on feed mill biosecurity. But in the meantime, there's also been another important point that I think we should spend a few minutes talking about that really emphasizes the need for a feed mill biosecurity plan and will help us understand why this topic is probably going to be one that's spoken about quite a bit in the near future. And so if you haven't already known, the final ruling of the Feed Safety Modernization Act was published last Thursday. And in this act, there's language that states that food animal production plants, which we would know as feed mills, will need to develop plans to mitigate specific and identified hazards. The focus there being on the word specific and identified within the language right there. But more importantly, they do define hazards as any biological, chemical, or physical agent that has the potential to cause illness or injury in both humans or animals. Now, consequently, we see really the importance of the emphasis on hazard control, hazard mitigation, on on control of what's happening there in the feed mills, especially the connection between the humans and the animals. What's that mean for us then? Under this definition, PED could be considered a hazard where a control plan would have to be developed. Other physical hazards like metal and plastics make sense, but hazards, such as chemical hazards like mycotoxins and pesticides would need to be addressed if they are identified within that feed safety plan. And so with that in mind, we come into this time right now where feed mill biosecurity is really a hot topic. And if we think about it, everybody thinks about biosecurity at the farm level, at the gate level. And I think it's time to really start expanding that role as we go forward. I really like this, the way that the FAO defined biosecurity as the holistic concept of direct relevance to the sustainability of agriculture, food safety, and the protection of the environment, including biodiversity. And so, again, I think this paints a nice picture of connecting all the dots in the supply chain when we start thinking about biosafety and biosecurity at the feed mill level. It begs the question then, how important is feed mill biosecurity to us? And if you were at my presentation last year when we talked about PED, I talked about a minimum infectious dose study that we conducted where we determined that as low as 200 infectious particles of PED when inoculated into feed was enough to induce infectivity. And to put this into context, an acutely infected pig will produce approximately 100 million infectious particles per gram of feces. And so the slide that everybody seems to remember is that 1 gram of feces from an acutely infected pig is enough to inoculate 500 tons of feed, with each gram of feed leading to the potential to be infectious from a PED standpoint. So consequently, the importance of really controlling PED transfer and contamination in the feed mill to minimize this small amount that's required to lead to infection is of great importance. That then will lead into the presentation that I'll give today, as well as some of what Laura and Tim will also be talking about. We're going to mention a little bit about the importance of overall biosecurity in the feed mill, but also spend a lot of time talking about controlling and minimizing hazards and risks. And so there's a couple different areas that we can focus on here. And one thing I would like to do is give some recognition to Roger Cochran, a PhD student in our program, who actually just finished his master's degree and wrote a nice literature review on feed mill biosecurity, and so captured a lot of this information from his lit review right there. But if you need some more information from that, Roger would be the man to talk to there. But definitely preventing entry at the receiving, Laura's going to touch on a little bit. She has some really nice pictures illustrating how to control some of that. You know, the other things that I'd like to mention, definitely from a supplier verification and a trust standpoint, very, very important to build that relationship with the supplier of your ingredients, not just the distributor that might be supplying applying them directly into the feed mill. Something I learned quite a bit in my previous job, but definitely having a strong quality assurance procedures and then a good quality control program to ensure that that quality assurance that you work so hard is maintained once those products enter the mill. Definitely prevention from entry from peoples and vehicles is another topic that Laura will touch on, have some really nice photos to look at that. But there are opportunities to have dedicated flows and isolation areas where, for instance, feed truck drivers do not access the feed mill as ways just, again, to prevent risk contamination. I'll spend some time today talking about preventing cross-contamination during the production process, focus on housekeeping schedules, talk a little bit about separate ingredient and finished production areas. And there's an example. We were in a feed mill about 2 weeks ago where they had separate and ingredient or incoming ingredient areas within the feed mill, and then the finished area also with filtered air from one side to the next. And so it's something that we've gone really the next step in making sure that there isn't any cross-contamination within the production process. I'll also touch on feed flushing and sequencing, which most of the feed mills are used to. Mitigation of hazards in the mill. Dust collection is a big one that I'll touch on here. Processing from a pelleting standpoint, some of the work we've done there at K-State, as well as some chemical mitigations, again, that Roger Cochran has been the lead on a lot of that. I'll finish up talking a little bit about preventing cross-contamination during loadout and during the delivery process with dedicated loadout areas, truck sanitation, sequencing of loading and delivering in the mill at the farm. Then finally, Tim's going to give a really nice perspective on some of the work he's been doing there at PIC, talking about biosecurity plans, but then really the assessment process, which is where he's had a big lead there within his team. So should be a good session for us today. So first off, what we wanted to determine here at a recent study we conducted at Kansas State University was in relation to PED, how much contamination can really happen in a mill. And so we conducted a study that we were fortunate the National Pork Board was able to fund, where we determined the feed mill surface contamination after processing PED batches of feed. And so we conducted this study with 3 different replications, which we'll consider days or 3 different runs through the system of a batch of PED-inoculated feed, which was mixed through a mixer, discharged through a bucket elevator, and then subsequently pelleted. And then, similar to a commercial mill, we didn't clean out the equipment, but we followed it with 4 sequential PED-negative batches to determine how much cross-contamination could happen from batch to batch. But also, we were able to take swabs of the environment to determine how much overall PED contamination happened within the mill after a PED-positive batch of feed was produced. And to give you just a little bit of a point of reference, we're really fortunate there at K-State to have a new feed mill that came online in 2013. We do make all of our research and our maintenance feeds in this feed mill, but we're fortunate also to have a little area right here, which is the Cargill Feed Safety Research Center. It's a 3-story BSL-2 hood, if you will. All HEPA filtered air, negative air pressure, shower out procedures, shower in procedures if you choose that as well too, with a multi-step decontamination, starting with a physical decontamination, going to a couple rounds of chemical, but then the final kill step is a process where we'll be able to heat the whole environment up to 140 degrees and maintain that temperature for 48 hours to really act to kill anything that might be left within the environment. So this area within the feed mill is set up, or has the capabilities to be set up just like any commercial mill. Has a 1-ton pellet mill with a conditioning system on top of it, going through a normal pellet cooler that you'd find within any mill, with the drags and the screws that you'd see, mixers, bucket elevators, and the ability to configure that however we want to. The nice thing also with computerized systems both within the containment area and outside, so that you can actually control and operate some of the equipment whether you're inside or outside of the mill. Give you just a little bit of point of reference of the facility. This is our first floor and our second floor of the facility, but it's really an open footprint right here that allows us to have a lot of flexibility in bringing different equipment in and out, but has a lot of area then to allow us to conduct all sorts of different kinds of studies. And so this is where we conducted this feed mill contamination project. And when we start looking at some of the results right here, I'll set up the slide just a little bit. On my vertical axis is the percent of samples, environmental swabs, that were positive for PED. The cutoff that we use right here between positive and negative was a CT of 45. and so a relatively high level. Along the horizontal axis was our environmental swabs at the baseline that we used to confirm that the environment was PED negative. And then we have the swabs after the negative control diet was made, no PED, after the PED diet, and then the 4 sequential flush diets, but then the environmental swabs after the first chemical cleaning with Synergize, and then bleach, and then after the 48-hour heat-up process. And what you see real quickly is we have 3 different lines, 3 different colored lines right here. The blue line would represent what we call zone 1. That would be the surfaces that had direct feed contact, so the inside of the mixer, the inside of the buckets as an example. The zone 2, which is the red line right here, would be surfaces that were immediately adjacent to where feed was present. So it would be on the outside of the mixer as an example, on the outside of the bucket elevator. And then zone 3 would be the structural surfaces like the floors and the walls, different areas within the environment right here. And definitely what you can see is a dramatic and significant increase in environmental contamination after processing that first batch of PED feed. If you look at the blue line, which had the surfaces that did have the feed contact, you can see a little bit of a reduction in the amount of samples that were PED positive. However, I'll keep this in mind, it's still over 80% of those samples were positive. And so we'll see this in some of my subsequent slides. This is probably a dilution effect in those surfaces. But most importantly, if you look at those areas that are completely or immediately adjacent to the areas where feed was in contact, we maintained 100% PED positive swab samples even after making 4 subsequent batches of feed. And so we'll show in my future slides that we do have an ability to reduce the amount of PED when we look at it within only the feed. However, if we look at the environment, and especially all the equipment that's immediately around where that PED is present, there's a tremendous amount of virus in that environment. And I think it goes back very nicely to some of Scott's original work with the Swiffer tests inside the bins, that this dust seems to be a real harbor for PED virus and can potentially act to spread that virus from barn to barn or from diet to diet. This slide then also shows the CT values of the swabs that we collected. The columns here is the samples collected after the PED positive diet, but then after the first through the 4th flush diet. Right here are the samples that were, the swabs that were collected from the direct feed contact. And you can see that we started with a swab that was about a 0.30. And as a point of reference, the feed PCR also had about a 30 to 31 CT. And so you can see that the environment, the sides of those contacts were about the same level of PED contamination as the feed had. As we sequentially added batches of diet in there, we saw a slight increase in the CT of these samples, which again probably is reflective of a dilution effect of feed going through the system. But more importantly, the surfaces that did not have any direct feed contact, we saw a very stable environment right there where it was able to harbor that PED after 4 sequential or 4 subsequent batches of feed. And so definitely something we'll echo through all 3 presentations today, the importance of feed mill biosecurity, the importance of monitoring dust and contamination within the feed mill. The real challenge that we have when we start thinking about what to do with this PED potential contamination is thinking about the feed mill, and because we've got a really complex system of very specialized equipment within a feed mill. Multiple points of entry and exit within the feed mill, multiple flows of feed and products within, and because of the specialized equipment, it's not normally set up to be easy to access, easy to clean, easy to decontaminate. And so we've got a really complex system that we're dealing with. And on top of it, normally feed mills aren't necessarily designed with biosecurity in mind. And so what you have right here, similar to slides that Laura's also going to show, the receiving pits are a major concern when people are driving across the pit with a dirty truck. But also what you see right here, these would be considered a clean screw conveyor within a feed mill. Normally in a feed mill, we define clean as that point at which no more feed is exiting the environment, exiting the system. And so you can still see there's going to be a certain amount of feed at the bottom of this. Here's the bottom of a bucket elevator, really, really high risk area right here. There's a large amount of feed in the bottom of that bucket elevator. Here's the top of a surge going out of a pellet mill into a pellet cooler, and then a ribbon mixer. All of these, again, would be considered clean in a feed mill environment. So easy to see how there could be potential for cross-contamination from one batch to the next. Now, the other challenge that we have is that the whole feed manufacturing process is a really really a big network of many different people, many different decision makers within the whole process. And you can see right here that one of the real challenges that we're going to have is really the communication, the education process of the entire team, making sure that everybody is following the same biosecurity procedures, because no matter how much these guys work on it real hard, if this loadout operator at 4:30 on a Friday afternoon says, you know what, I'm going to catch up for next week and make my sow feed here and go and make this one delivery so I don't have to worry about it on Monday, that's all it takes to break that sow farm because they didn't have the proper biosecurity as they're going through. And so definitely a daunting task in front of us when we start thinking about feed mill biosecurity. I talked a little bit about the environmental contamination study that we did, and it was also part of another study where we looked at flushing and sequencing as a potential way to prevent cross-contamination. And so in this study, again, a National Pork Board funded this project for us. We first processed a non-PED batch of feed to charge the system. The system was a mixer that was discharged into a bucket elevator and then went through a spout and was collected at that point. We then processed the PED-inoculated batch of feed, 4 sequential non-PED batches of feed, again, replicated the entire process 3 times. And just for more explanation, between each of these 3 times, these 3 days, we went through the entire decontamination process in our mill. So we always started with a baseline with absolutely no PED contamination in the environment. Then we're able to measure cross-contamination both by PCR and bioassay. Here's the results of the samples as analyzed by PCR analysis. The columns being those samples collected after the PED diet was processed and after the 4 sequential flush diets. Here in the top portion of the slide is the number of samples that were collected and the number then that were positive for PED. And so you can see after the PED diet, all 9 of the samples we collected were positive. However, samples collected after the first sequence diet, only 7 of the diets were positive for PED. And then with the sample collected after the bucket elevator, there was actually 2 samples that were collected that were PED positive, even though we didn't have any from the feed that was exited the feed or the mixer right there. And so sequencing 3 and 4 diets, we had no positive PED samples collected from the feed samples here. CT of the feed samples, around 30 to 31, as I mentioned, for the PED diet. But then you see definitely an increase in the CT count, which means less PED RNA being able to be detected, which is good, suggesting, again, that sequencing could potentially minimize risk of PED cross-contamination. And again, no samples detected here after the 3rd and the 4th sequence. Of importance right here, when we went to bioassay, we chose to use the samples collected here from the mixer. And so we also only did the bioassay from the PED diet and the 1st and the 2nd sequence diet thus far. It's important to keep a point or keep in remembrance of specifically this point right here as we go to the next slide, where we show the number of pigs that actually develop PED infectivity during the bioassay. This again, the columns right here are the number of pigs that were detected from 0 to 7 days post-inoculation, with the final sample being 7 days post-inoculation from the semen or the fecal contents. The number of pigs then that were detected were infectious from the PED. As we expected, our non-PED diet, our control diet, none of the pigs developed infectivity. 100% of the pigs that were fed the PED feed all developed infectivity. However, after sequence 1 and sequence 2, we only had a small portion of the pigs that did develop infectivity, about 1 pig on day 2 post-inoculation, that then resulted in development of infectivity in the rest of the roommates right there. The other 2 pigs in that room also developed an infectivity through the rest of the study. Remember, though, that the feed sample we collected for after sequence 2 was PED negative, if you will, based on PCR analysis. Really what that means is that we did not detect PED at the level or at the break point of a CT of 45. However, even though that we carried that sample on to bioassay, we still were able to lead to infectivity in these pigs. And so really concerning right there what happened, and ultimately shows that we can potentially lead to infectivity even though we don't detect it via PCR analysis. So what's the study showing us? It's definitely sequencing reduces the PED detection in feed. We saw that in the previous slide. Also reduces infectivity. However, we did show that carryover still can occur from one positive batch to feed, even to subsequent batches that were PED negative. Again, the biggest concern is what happened in that second sequence where we did not detect the PED in the feed, however, still led to infectivity. Just as a reminder, we conducted this study very similar to a commercial mill. We processed that PED batch of feed and then opened up the port at the bottom of the mixer right here, let it run empty, banged on the sides, but we did not go and decontaminate. We didn't physically clean the inside of that mill. We subsequently followed it back then with the negative batches of feed. And so consequently, this is what the insides of the mixer looked like. This is the bottom of the bucket elevator after that PED batch of feed was processed, also after the subsequent batches of sequence feed. And clearly what you can see, if no one has, or if you don't have that much experience looking at a bucket elevator, this is definitely a high-risk area, because the way this machine works is there has to be feed at the bottom of this side to be able to fill those buckets and carry it up to an elevated level. So definitely something we need to be thinking about. I want to bring it back then, connecting both parts of the study, the PED infectivity portion as well as the environmental swabs. In the middle columns right here, you see the feed samples that were collected at the mixer and the elevator after the negative, the PED feed and the 4 sequence batches, but then the environmental swabs from the surface contamination. So again, just to tie it all together, after sequence 2, we didn't have any feed within the mixer that was PED positive. After 3, we didn't see anything that was positive or PED was detected after the bucket elevator. However, still there is a wide range in a highly contaminated environment. Even after all of these samples were collected, we were coming up with 100% PED positive environmental swabs right here. And so again, the risk of environmental contamination is really high in the case of PED. I want to bring that into going on to another area for us to consider, just housekeeping within the feed mill system. Here's a mill that I was in earlier this year. It's actually a sizable mill. They feed about 300,000 pigs each year out of this mill. Here is their micro room, if you will. This is what they're making diets for. What you can't necessarily see as good in this picture is we've got about a ½ an inch of vitamins and minerals and amino acids and everything else sitting here on the floor. You can see it kind of piling up across the scale right here. Definitely, if they have a housekeeping program, it was non-existent for a long period of time before I entered the mill. The interesting thing that we also need to be thinking about, though, is here's the same mill. Here's where they dump all the hand ads. Right at floor level, which, what's that do? It makes it convenient to sweep all the dust in, right that port, get rid of that dust from a housekeeping standpoint. The other interesting part about this mill is actually what you can't necessarily see right here. This is a loading dock. So you can back your pickup up right here, unload amino acids, unload a pallet of this or that, all within 5 feet of where your micro-ingredients are being dumped into your mix. That consequently goes in the feed that you're producing. And so really, really high risk, something we need to be thinking about from an environmental contamination standpoint. Clearly, the amounts of dust in this environment was atrocious. Now, the nice thing, though, about the story is that they were in the process of making a new feed mill, which I was excited that I wouldn't have to be dealing with this environment anymore. However, they were also really excited about their dust collection system. Here it is, the Camphil air pollution control system right here. They went out and showed me their equipment right here, and I was excited to see it. And then all of a sudden, my jaw dropped, because what exactly were they doing? They were doing an awesome job of collecting dust, but then they also installed a drag underneath the dust collection unit to be able to add that dust back into the feed. I mean, no secret about what they were going to do with the dust. Sometimes they'll collect it in a tote bag or something, and maybe they'll tell you they're going to dump it in the trash can. But it's pretty clear what was happening right here. Now, everybody probably understands when a millwright goes to design a new mill. One of their charges is to make sure that there isn't any shrink. So by golly, they paid for that dust going across that scale. They're going to sell it on the way back to the outside there as well too. And this is something that, if there's any big take-home message from my presentation today, this is the one that I'd really echo to you: is make sure and go back to your mills, ensure they're not dumping that dust back into the feed. Especially as we're getting into the new crop corn harvest and the mycotoxin issues that people are afraid about, this is going to be a high area of contamination as well too. So let's get this process stopped as quickly as we can. We also did some work there at K-State looking at pelleting and its ability to minimize PED risk. I showed the first study last year here at the Leman conference where we processed 2 different doses of PED feed through a combination of 3 different conditioning temperatures and 3 different times, measuring PED survivability. If you remember my presentation then, I was able to show the CT values of the feed, but then there's a collective sigh when I had to tell everybody that we hadn't yet conducted the bioassay yet, and so we didn't know really what it meant. Subsequently, we've learned what that process really does from minimizing PED risk. We followed up with another pelleting study where we looked at titrating lower levels of temperature, 100 to 160 degrees, at PED survivability as well. Again, as I mentioned in the first study, 3 different times and conditioning temperatures. Low dose that had a feed that had approximately a CT of 31. The high dose had a CT of 24. When we did put that feed through the pellet mill, we saw a rise in the CT values, which would suggest that less PED RNA was being detected. The great thing from this study is that no matter which of these 9 diets here, the 9 diets here, we fed the pigs, we did not develop any infectivity of this feed. And so we were able to demonstrate that the pelleting process was effective at minimizing PED risk, at least to the level of the temperatures, the lowest temperature of 155 degrees with a 45-second retention time. That then led to the reason that we conducted our next study, where we've looked at 15-degree increments from 100 to 160 degrees conditioning temperature. Did this at a 30-second retention time to really minimize how much time that was the feed lasted in that conditioner. Had PED detected in all of the samples, basically, through 130 degrees, and then 8 of the 9 at the 145 and 160. If you looked at the CT of the feed samples, as it was processed, again, as a point of reference, the PED unprocessed feed had a CT of approximately 30 or 31. And we saw an increase in CT count, less PED RNA being detected up until about 130 degrees, then a relative plateau above 130 degrees right there, which matches up really nicely to the bioassay then that we conducted, where, again, from 0 to 7 days post-inoculation, this is the number of pigs that were led to PED infectivity when offered the feed. Again, like we hoped, no PED infectivity developed in the negative control diets. However, in the feed that was processed at 100 or 150 degrees, we were able to demonstrate that PED infectivity could occur. However, nothing occurred above the 130 mark, and so consequently, based on this study and the previous study that we had too, it looks like somewhere between this 115 to 130 degree Fahrenheit mark is a certain break point, or at the very least 130 degrees is the target that you should be looking for. The important thing right here that Cassie also illustrated in her presentation yesterday is we really need to be mindful of how much feed we produce actually hits these target temperatures. Because there's times during the pellet mill startup, and there's times when the steam is turned off when the die is plugged, where we're not hitting even the 130 degree mark. And so we need to be cognizant that if we're using a pellet mill as a feed mitigation tool, that we're actually hitting the target temperatures that we want to. Touch just a little bit on chemical mitigation, and one of the reasons that we really like this concept is that there's the potential for residual benefits from chemical mitigations that provide protection through the feed delivery and to the farm. And the real reason that that's a benefit is because, as opposed to the pelleting process, which is only a point-in-time mitigation step, there's always the possibility that pelleted feed can get recontaminated sometime within the feed supply chain. Some of the early research that we've done, some of the work that Scott Dee's been doing as well, show that the chemical treatment benefits are ingredient matrix specific. And definitely everybody's familiar with some of the formaldehyde work that, again, Dr. D has conducted, as well as some of the work that we've done here at K-State. And just one real quick slide, since we showed it last year, as well as Cassie mentioned it yesterday. One study from Dr. Cochran's study right here, looking at different chemical mitigants on PED inoculated feed. Again, this was a post-processing recontamination, so we inoculated the feed with the chemicals and then placed the PED into the feed after that. The black line is your point of reference. That's the non-treated feed. What's interesting here, and something that we're following up in other research, is our medium chain fatty acid and our essential oil lines, all showing that there could be potential benefits when those are included in the diets. The other thing as we start wrapping this up, preventing cross-contamination during loadout and delivery. Definitely flushing and sequencing are important within the feed manufacturing process, but we also need to be thinking about it when we're loading out bins and loading into truck compartments, as well as really paying attention to sequencing deliveries from high to low risk farms and from clean to dirty farms. And one of the things everybody needs to be aware of within that feed production process is really how their feed trucks operate. So here's a situation where hopefully we don't ever have to have a situation where we've got sow feed and finished feed on the same truck, but we need to be aware, and especially like a case like this, where the feed truck always empties from back to front because of the way the sliding gates work. And so in that such a case, we have to make sure that we load that sow feed on the back so it's unloaded first before we go to the finishing farm. One of the other things we really should get into, make a better habit of, is visual inspections. Here's the inside of one of the compartments on top of a feed trailer, if you haven't noticed it. But going in, making the effort to crawl to the top and make sure it's clean before you dump in a feed, especially for a sow farm or nucleus, would be really important. Doing the same thing within the feed mill, within the bins, would be another key step to be able to take. Looking at the process once we deliver the feed to the farms also is an area. I think maybe even Laura will mention this a little bit as well too. Having booties, if that feed truck driver has to exit the truck, and in this case most of them do, to be able to open the bin, to be able to operate the truck, but making sure they're protected from collecting contamination or recontamination back into the truck. The big thing, though, again, is making sure that the feed truck drivers never enter the barns. I mean, this is a big no-no there as well, too, and being able to prevent contamination. Again, from a delivery standpoint, considering dedicated feed transport, especially for your high-value farms, the hubs of your systems, the nucleus, the multiplication, the bore studs, is really a key point. The washing, the disinfection of the feed trucks is something that needs to be happen or needs to be considered in addition to only our animal delivery trucks. That includes the cabs from the floor mats and all the equipment in there. Finally, one of the things that we also need to be thinking about is how we design some of these barns, and especially in the feed delivery system. So, I mean, it's clear from some of Dr. D's work that when you place a bin at the backside of a barn where all of your exhaust fans are pushing air, that this is going to be a highly contaminated environment if it's a PED positive barn. And not only is there going to be PED on these bins, potentially inside, but when that feed truck parks right here to be able to unload the feed, that truck is going to exit that facility being also a very highly contaminated situation. So something we need to be keeping in mind, and just ensuring that we connect all the dots within the system when we start thinking about a biosecurity plan. So just concluding marks, definitely feed mill biosecurity. It's an evolving concept, something especially in relation to PED, but also with the new FSMA guidelines we'll be paying a lot of attention in the near future. Lots of people involved with it in a very complex system, which makes it a difficult challenge to implement. Although contamination levels may be low in some feed mills, they're challenging environments to be able to decontaminate. And so really what this means is the number one goal of the whole process is to ensure that contamination does not occur from the very beginning. Then what we've shown in some of our research, definitely feed sequencing, pelleting, chemical mitigations, all have some effectiveness in mitigating PED, both from a PCR analysis standpoint, but also from a bioassay and infectivity standpoint. So